So this is HTCondor 9.0 for admins. I just performed the most basic admin function there. I turned something off and turned it back on again. So we're subtitling this. Usually admins are ahead of the game when wanting to upgrade systems, but it's the users that hold them back. But with 9.0, this talk is going to explain why users will be begging you to upgrade their Condor. Now, 9.0, as everyone said, has a big release. I think it's maybe the biggest release of Condor in 10 years. And the biggest part of this big news, there's a lot of it, is that Condor is secure by default. We've done a lot of work improving the security in a number of dimensions for Condor here, but out of the box, it's secure, meaning that all communications are encrypted, and we have strong security, not the host-based security that was the default since, at least 20 years. Now, the bad news here is upgrading an existing Condor pool, especially if you're using the default host-based security, will probably break your existing configuration. And we apologize for this a million times over. We could figure out no better way to do this. So you have three options here when upgrading Condor. First, you can revert to the existing.
Sorry, Greg, to interrupt you, your slides are not advancing.
My slides are not advancing.
We are still sitting on your title slide.
Oh, that is interesting.
Now you just moved on?
Okay.
There we go. Three options.
There we go. We're doing little funny things today. So we have three options. We can return to host-based security with one line. You can reinstall from scratch. Now, hopefully Todd, Aaron Rodgers, 2-minute drill earlier showed you how to do this. I apologize to our non-American users or our non-American football following users. Aaron Rodgers is the leader of an American football team who's very good at scoring quickly. He looks something, now I've lost everything. He looks something like this. Getting back to this, our three options are reinstall from scratch, return to existing host-based security, or configure ID tokens-based security. And this is a new security mechanism that's in 9.0. It's not as hard as you might think, and we hope this is the future of security in Condor. We've had a lot of security mechanisms, Kerberos, the Windows mechanisms, GSI, certificate-based, host-based. They've all had some downside. We believe, we hope, that our new ID tokens-based security system for Condor daemons will fix all the existing problems, and it'll be the main security mechanism securing Condor going forward. And I'm not going to go into the painful details of this, but the release notes in the manual have all the details. As Todd said, this is on the Read the Docs site. That URL, which you should have memorized, is htcondor.readthedocs.io. We've done a lot of work in upgrading the manual and making it easier to understand and removing a lot of old cruft from it. So please, if you have questions, htcondor.readthedocs.io is the place to go. Now, install from scratch is easy, and we've built for admins a new service called Get HTCondor and a new script that Todd demoed, and Todd Miller is going to talk about this further down the road. So, getting back to ID tokens, this is our new security method for Condor. It's capability-based, and this is a big thing. It's not identity-based, as you might think from the name, but it allows you to say, well, I'm willing to give the capability to advertise a SCED or to just submit jobs. And as this is really, we think, the future of security to be capability-based and not identity-based. And sort of getting back to the philosophy of Condor, this is really important in a distributed system where maybe you don't know the name of all the things you're working with, or you don't care to know about the names. You just want to know what they have access to do. It's also very fine-grained, so it's not just I have read or write access, but very specific capabilities. And perhaps more importantly, there's no third-party service needed. Everything needed to run ID tokens comes with Condor, is built into the Condor daemon. So you don't need to set up the equivalent of a Kerberos KDC or a certificate infrastructure or have a Windows domain controller or anything like that. And Brian Bachman will give a full talk on this, I think, later today. So ID tokens, we're very happy about this, but this is a big, big change. Now, after bragging about all the things we do well, obviously the one thing that we do not do well in Condor is name things. So something else we added, in addition to ID tokens, which is also security-based, is called PSI tokens. Now, unfortunately, this shares most of the same name as ID tokens, but it's really for something very different. Whereas ID tokens is mainly for security for within Condor, from one daemon to another, one tool to a daemon. Psi tokens is mainly designed for security to non-Condor daemons, security from a job to a non-Condor daemon. In particular, it's very common for authenticating or getting access to XUD or other storage systems. So with this, with Psi tokens, and the reason your users will love this, is jobs can get their files without sending a password in the clear, which is obviously horrible, sending password in the clear. So with the appropriate Psi token that Condor can send along with the job, jobs can access their data on third-party systems without sending the password in the clear and without compromising security. And we believe this is going to be an emerging standard for scientific data access. And we see XUD and other storage systems adding support for Psi tokens. So we're super excited about this. For non-scientific data access, there's a more widely used protocol called OAuth2. This is the protocol that when you do your two-factor authentication, you pop up to Google or Amazon or whatever, is doing authentication to some third party that you maybe already have an account with. And again, this is also very useful for storage. This allows jobs to get their data directly from some third-party commercial storage system like Box or Google Drive, again, without sending the password in the clear. And with this, storage, the admins are going to love this, becomes someone else's problem. So you don't have to configure storage. You don't have to manage the storage. You don't have to back up storage. If users already have their file or data in the cloud, in Box or S3 or Google Drive, their jobs with an OAuth2 token can directly fetch and put data directly from the cloud, again, without sending their password. So we believe this is just a huge step forward. Now, this doesn't come for free, like few things do. Admins need to set up a CredD in order for this to work. So the CredD is a daemon that exists on an access point that manages and holds on to the credentials that OAuth2 needs. Now, to set it up, you use feature OAuth in the config file on the submit machine. You set up a web app or a web server on the submit machine, and you need to register this SCED on the service to let it know that it's willing and available and set up to get tokens from the third-party service. And again, I'm not going to go into painful detail on all of this. All of that is in htcondor.readthedocs.io. So working through once you've done this, working through the way the users see this, is they just add lines like this in their submit file, and then they run Condor submit. And then Condor submit will block and wait, and it'll print to the screen something like, please go to this big long URL. And that will redirect you to the authenticator service for this particular cloud service. And then it will get an authentication and send a token back to the SCED, which the SCED will put in the CredD. After that, Condor has your credentials and will send it securely along with the job. And those credentials can be very fine-grained. So you can say, depending on the service, I just want to be able to read my files, or I just want to be able to read files in this directory, or I just want to write this one file, depending on the service. And again, we believe that this switch from identity-based access to capability-based access, which Brian will talk about in painful detail, is really the way forward and the only way things can work in a distributed environment. But that's not the only thing we've done with security. We have AES on by default. And now, out of the box, everything is encrypted. Remember, before 9.0, out of the box, almost nothing was encrypted. File transfer wasn't encrypted. Sending the executable over wasn't encrypted. Things which were absolutely required to be secure, like capabilities to access machines, were encrypted. X509 certs were always encrypted, but very few things on the wire were encrypted. Now, by default, everything is encrypted on the wire without you doing anything. And because this is AES, we hope there's going to be very little performance impact. That may be something that admins want to look at. Now, I want to emphasize that because we do care a lot, tremendously, about backward compatibility, the AES encryption is negotiated for. So when one daemon talks to another, it knows if the other side, maybe it's an older version of Condor, maybe it's turned off for some reason, cannot support AES, and you can configure it to talk to an older non-AES supported daemon in a non-encrypted way if you want to interoperate that. We almost got FIPS mode. I don't know how many people know about FIPS mode, but it's a standard by the by the federal government that requires you not to use certain outdated crypto algorithms. We almost got this into 9.0. We had one place, I think, where we accidentally are still using MD5, but hopefully very, very soon, there'll be no MD5 left in Condor, which means FIPS mode will be on by default. So for those admins who need FIPS mode, who likes FIPS mode, there won't be a special build of Condor anymore. In the scheduling department, we added ceilings. And a ceiling is an absolute limit on the amount of slots or cores that a particular user can have. In the past, we only had limits, which we called quotas on groups. So this allows an admin to set an upper bound on the amount of resources that any one user can use across the pool without creating groups or accounting groups. That was a big ask that a lot of sites have been asking for. Another user request has been that DAGman throttles are now dynamic. So DAGman has always had these throttles that you could specify the maximum number of jobs that are running, that are idle in the queue, and the pre and post scripts that can be running. Now, kind of the bad thing about these throttles was these were all static before, so you had to know what to set these to, and invariably you'd get them wrong because you didn't know. Now, the Condor QEdit tool can change these, and DAGman will update in real time, which is really handy because you don't know that you're running too many prescripts until you are. There's a few other DAGman features we've added. We've added provisioner nodes for the cloud. So there's a special kind of node that runs essentially alongside the DAG for the duration of the DAG. And the idea here is this provisioner node can create with maybe the Condor Annex or other tools, resources for the rest of the DAG to run on. And as long as that provisioner node is running, the rest of the DAG can run. And that provisioner node, when the DAG is run, can shut down the cloud resources at the end of the DAG when it doesn't need them anymore. Another cool feature, Condor DAGman-dot. We've supported dot, the dot output format in DAG for a long time, which prints a format which can be easily changed into a graphical representation of the dot. I think you've seen, if you've been to Condor Weeks before, you've seen big pictures of DAGs as graphs. These are all generated by dot. But in the past, the only way to generate these dot files was to run the whole DAG, which could be a long and painful exercise. Now, if you run Condor DAGman-dot, it just prints out the DAG. So if your users are trying to debug their DAGman or want to see what they look like, or maybe you want to show off to maybe a funding agency, Condor DAGman-dot will print this pretty DAG without running the whole DAG. There's a million little things that we've added. We've done performance improvements in the SCED, in the negotiator, in class ads in general. We've done a lot of tool support for analyzing the code, both dynamically and statically. So hopefully there's 0 or fewer memory leaks or security issues. We've added Python 3 support everywhere in the bindings, which is a big thing. So I know a lot of our users are moving from Python 2 to Python 3. We've added new tools for debugging. There's a great new tool, class ad eval, which is a standalone tool which evaluates class ads. So a lot of times, those of us who are writing fancy class ad expressions want to be able to debug them or see what they do. Or, for example, I know that the class ad regex function takes 3 arguments, and I can never remember the order. So class ad eval is a tool that lets you debug class ad expressions just by writing them, which is very, very handy. The things that may seem little but can be vital to everyone is we've added new platforms. We've added EL8 and Ubuntu 20. We've removed old platforms like EL6, which enable us to do some other things. And with these platforms, as Todd alluded to, we've added all kinds of packaging. We've added Docker Hub. Condor is available via Conda, say that 3 times fast. And we've set up these new native repo streams for the development of the stable and the nightly series. Another thing that people have been really asking for is faster or more flexible access to history ads. The Condor history tool reads the whole history file and thus is kind of slow and it's kind of hard to query. So of course, what everyone's interested in is NoSQL databases. So we added a tool called Condor Ad Stash, which reads job ads, maybe from the job history file, maybe from the start key history file, and pushes them into an Elasticsearch database. This is a Python 3 script that uses the Python bindings. And once you've done this, Elasticsearch will have your job ads in JSON format, which is kind of handy, because then you can write ad hoc queries against Elasticsearch, like this one, which shows why my jobs are taking a long time to run. In our pool, we've even written a small Python script that runs nightly out of CondorCron and produces a nicely formatted report to say, well, you know, what's going on with this pool? I would like these 17 statistics. We don't ship this script with 9.0, but I think we will very soon. A lot of these statistics may be specific to us. So if you have your own job-related statistics you're interested in, Condor Ad Stash plus a little bit of Python can generate all kinds of great reporting. Continuing from class ads, perhaps the most powerful tool an admin can do on the Smith side is schedule transforms. These are like the admin's chainsaws that allow an admin to change any job class ad attribute as it comes into the schedule, if it's coming from Condor Submit or Python, and lets you make assertions to say, well, I'm only going to accept ads that maybe have an accounting group set, or I'm going to change this job ad from the vanilla universe to Docker universe because I know what I'm doing. But schedule transforms have been kind of tricky to write, especially if you had multiple transforms, you need to rely on the order that they fire in. So we added a new transform language that are easy to write, especially with multiple ones that have a defined order that they fire in. And TJ is going to give a whole talk about this later this week. We also have new Condor drain-reason. So if you were draining a pool with a Condor drain command, it's very handy. It takes a -reason string, which can just be printed out, to explain why to yourself, to other admins, or maybe future you, why you're draining a particular machine. And the defrag daemon, which remember runs Condor drain itself, now passes defrag as the reason, which is handy. So you can see if a machine is draining, you'll know if it was you or maybe some other admin, or the defrag daemon itself was started this draining. And perhaps most importantly here, if the defrag daemon sees that a machine is draining and its reason is not defrag, it knows that some human being is defragging this and excludes this machine from the set of machines that it selects for draining. We've talked about data flow mode a little bit. And again, this turns jobs into jobs like make. So with this knob that you can set in the config file, shadow skip data flow jobs equals true. If your job has an input sandbox and an output sandbox, and the output files all exist, and they're all in the M time of these output files, all more recent than the input file, the job is skipped, just like make. Moving to the end, everyone loves to run their containers. We've made a bunch of improvements to containers in our own sort of container universe, the C group, in terms of passing the NV flag to Singularity and Docker if request GPUs are set, and forwarding all the appropriate environment variables. We now support turning off networking in Docker jobs. So Docker networking equals none. So if you want to have a very secure container that has no inbound or outbound network at all, you can say Docker network equals none, or Docker network equals host. And with Docker network equals host, the NAT is turned off, and you use the host network, which we found to be very valuable because the Docker NAT does not support IPv6. So if you need IPv6, you need to use the host-based networking. So that's kind of a big, fast summary of all the important admin features in 9.0. We've added a ton of things, so I hope to hear from you in the in the panel discussions and the Q&A sessions later. Thank you, and have a great Condor week.